Hello guys, welcome back to my channel. So today we're gonna do a video and we're gonna talk about this Marantz model 2330B. Vishal bring it to me because I need to do a service on. Thank you Vishal, because you are trusting my work and you bring stuff that I can fix for you. So without further ado, let's jump on this video. This audio receiver amplifier was built between 1977 and 1979, so I'm expecting to be around 44 or 42 years old, this amplifier. So if was never serviced, I'm expecting to find inside the original capacitors, and imagine after 40 years old capacitors, especially the electrolytics, the electrolyte inside might can get dry and the capacitor doesn't work how they should. So this amplifier was designed on USA and then was manufactured in Japan and claims to do 130 watts per channel into 8 ohms load. So let's hook up two speakers, let's power, and let's see how it's doing. Okay guys, I hook up already the speakers. Let's power on and see how it's doing now. Let's now to power on. Oh, I didn't expect to have that noise. Looks like this noise is coming only from one channel. I didn't expect to have that noise. So here is not a simple just a simple service, so it's also a repair on that it will gonna go on this audio receiver amplifier. And I didn't have any spare parts or nothing, so I think this video I'm gonna do in two parts. So this part I'm gonna do diagnosis and understand what I need, what is wrong with this, and what I need to replenish, and what I need to order to make a list. And I'm gonna come with the second part when I'm gonna change all the parts and do a audio test, and then do again an oscilloscope test, and let's see if it's really give me 130 watts power into 8 ohms. Yes guys, so please leave your comment in the comments below. Let's see if you're gonna have this amplifier in your lab and you power on and you have this noise. What do you think that can be wrong on it, and what are the steps that you are starting, from where to look and what to look in order to identify what is broken inside? Because something is broken in one channel is working perfectly, like this channel doesn't have any noise, but this channel is bringing up that noise. So please, leave your comment and let me know how it will gonna be your steps in fixing this amplifier. Okay guys, so let's open this one to see how it's inside and look for what is wrong with it, because that sound doesn't sound too much good. So we're gonna open, we're gonna bring the camera close to it and look how is the build inside and try to diagnose where the problem is, because we really need to understand and fix this amplifier. So I try to bring it to my working bench. It's really big and huge and heavy. Really I don't have space where to put it on my working bench. I didn't have a very large working bench where I can work on big amplifiers like that. So let's start open this one and see how is inside, how is the build, and look for what's wrong. Okay, so this is how look inside. A very nice build, a very big transformer. Oh, it's really big one. Two big capacitors. Oh, these capacitors are already two in series of 6,800 microfarads, 80 volts. So I have here two in series, two in series. So in this case, I believe this is a dual secondary power transformer. So this means it has one secondary for one capacitor and for two capacitors, because this one are two capacitors inside, and bridge rectifier, and the same also here. So first things what I'm gonna do, because it looks really dusty inside, I'm gonna use a very soft brush. I'm gonna start brushing a little bit to get rid of all the dust inside. So yeah, it looks much better now after a little cleaning. Yeah, so it's really a nice build. So here we have a block with some power supplies, definitely this one, and also the speaker protection, definitely this one is here. Then here we have the radio. Here we have the amplifier itself. And should be down there where are the potentiometers. I can see there is a board where definitely are the preamplifiers. I don't know if I have a phono entrance. Let me have a look what has as an input. So as the input has the phono. Yeah, has also phono input. So should be also the phono input over there if it's not straight away next to the connectors over here at the back. So let me turn it over and then open also at the back panel, because looks like all the power connection over here. And for me, this sound that is giving me, and only one channel, and now that I saw that there is two separate power supplies for each channel, it's nothing to do with the power transistors or some transistor that it's short or something, because if it was something short, definitely the fuse was blown. So here, definitely that sound bring me to a power issue. So mine can be the rectifier board that doesn't rectify good the DC voltage for the one channel that make that noise, or maybe it can be capacitors. So yeah, let's turn it over and let's open also the back side and let's start measuring the power supplies to see if are okay. Okay, so here we go in the back side, the bottom side. Let's just pass quick a bit also here with this brush, removing a bit of some dust if there is. Okay, and let's have a look what we have here. That's the selector, and pretty sure I believe here is the phono stage also. Or maybe, as I say, in this board, because here is all the potentiometers and all the preamplifier stage, and this is the amplifier stage. And see how I mentioned before, there is dual capacitors connected already in series in order to make 0, which is ground, positive and negative. Same also here, 0, which is ground, positive and negative. Definitely this kind of capacitors, they are gonna be difficult to be found around. I think I have in stock same capacity, like 6800 microfarads, only that the voltage is more higher, it's maybe 100 volts. I'm gonna see if I'm gonna use that one. Are small and but are doing the job. So if I'm not doing any upgrade here to go more in higher capacitance, definitely I can use those ones. Here I can see there is, as I say, the 2 bridge rectifiers over here, some resistor and some capacitors in order to reduce a bit more the ripple. And let me bring the multimeter and put power on this one and measure the voltages, because as I say, the noise is telling me, oh, one of this is powering one channel that is making that noise, doesn't rectify how it needs to be rectified the AC voltage to DC voltage, or maybe one capacitor is gone. So I bring the multimeter like that, I can measure the voltages here. And as I mentioned, I have this kind of capacitor, so I have 4 of them the same. So I'm gonna use these ones for this project. So I'm gonna take them off, and definitely I'm gonna have a lot of space over there. I'm gonna make a PCB board where I'm gonna mount the new capacitors, and I'm gonna mount it there, and I'm gonna come with the wire from this side to the other side to connect them. And as I say, let's give power a bit and measure the voltage across this capacitor. Let's see if we find any issues here around. Okay, so now let's connect the ground to the ground, which is the black one over here. So I'm gonna connect to the ground over here, and then I'm gonna check to don't touch nothing over here. Should be here the power on. So the power is on, the relay are clicking in. Let's put this one on voltage. Volts over here, and is on DC, yeah. So let's start with this first. Here is telling me that I have need some way to watch also. Yeah, it's telling me that we have 68 volts positive. Here is telling me that I have negative 68 volts. Here I have, here I have plus 45 volts, and here I have minus 68 volts. Okay, so in this case, that's a problem with the power supply. So I have less voltage on the positive side than on the negative side. So the only things to understand if the capacitor is gone or the rectifier doesn't do properly how it needs to do, I'm gonna desolder these wires here, and I'm gonna measure the voltage without capacitor. And if I have the same, exactly the same voltage without capacitor, this means the rectifier it's okay, and we have a problem with the capacitor. Maybe it's in short and drop the voltage too much. Or maybe it's not in short, maybe it's just dead and don't smoothing the voltage. So let's see, I'm gonna bring here my small T12 desoldering iron, and I'm gonna desolder this wire, and we're gonna measure again the voltage across those wires. Okay, so I bring my T12 soldering station. Is a very small one. It's really good for moving around when I need to do some soldering in some other place, not in my working bench. So let's turn on this one, and let's bring it to 400 degrees like that, because I get also the really thick tip. And let's try to desolder this stuff over here. Let's try if I can do with the opposite hand. Okay, so positive is out. Let's see also the negative now. Negative is out. Okay. So until here we are alright. Let me keep them together so that I can measure then the voltage. Maybe if I can solder them a bit to stay together, I can measure the voltage. Because definitely those one are the one that comes. So one is coming from the Y. Okay, so maybe if I'm gonna just attach them a bit just to make two measurements, and then let's try now to see if I can. Okay, they are attached together, these one are attached together. So now we can do some measurements to understand if here I have now exactly the voltage. This means the capacitor is gone. So let's bring back my multimeter over here. Let's put 7 voltage. Let's connect the ground to the ground, which is this one here. Okay. Let's turn on. Power should be here. Yeah, power is on. That one is in. So here we have 68. Negative 68, positive 45, negative 45. Okay, so the rectifier is doing how should. But first I would like to make sure that I'm discharging the capacitors here. And let's try to measure the capacitance. So let me put in capacitance over here, and let's try to measure the capacitance. Let me just turn off my soldering station. Okay, so here to here, here to here doesn't measure nothing, just tell me 3.4 nanofarads, and here to here yeah, 7,000 microfarads. So yeah, that capacitor here, so from the ground to positive, it's wrong. See, it's just measuring 3.3 nanofarads. So yeah, so definitely I'm gonna try to use those 4 capacitors. I'm gonna make a PCB board and I'm gonna eliminate this capacitor from here, and I'm gonna make a board on the other side and put them on the other side, because definitely I don't know if we can find now this capacitor that are old since this one was built. So this one was produced, as I say, 1977 to 1979, so 40 years old capacitor. So in this case I'm gonna also have a look for all the capacitor around, because it looks like was never changed, nothing inside, don't see any kind of soldering around here. So this means I need to check all the electrolytic capacitors, because if it's this one failed, anyone around it can fail for the same age, more than 40 years old. The capacitor and electrolytic definitely will not work now properly. So better if I make a list. I look for all the capacitor, I'm gonna make a list and order new electrolytic capacitor, and I'm gonna also change all the capacitor around. So this was the content for this video, because as I mentioned, I don't have any components, and also after this I need to look inside and look for all the electrolytic capacitor. I'm gonna make a list with all the values, and I'm gonna place an order. And once I'm gonna receive the capacitors, I'm gonna start to do the second part of this video, where it will gonna be changing all the capacitors, putting the new smoothing capacitor inside, give a sound test, give an oscilloscope test, and yeah, stay tuned. Please subscribe, activate the notification bell, like that you'll not miss the second part of this video. And thank you guys for watching this video. I hope you enjoy it. I hope you find it with a lot of information, how to find and how to understand from where to start to look if something is issue with an amplifier, depend which noises give you. Because as I say, if it was something in short, the fuses was blowing, but the fuses was not blowing. So this means that channel in the positive rail didn't have the smoothing capacitors, doesn't have enough voltage, and the voltage was not smoothed, the DC voltage was not smoothed, so that's why it was full of AC with ripples, and that's why it was that noise. When it's a short, the noise it's a bit different, so that's why bring me to start from the beginning to measure the voltages straight away, because like that, see, very easy, we identify what is wrong. So a capacitor failed, so that's why my plan is to change all the capacitor. 40 years old electrolytic capacitors, they will never work good after 40 years old. So stay tuned guys, please subscribe, activate the notification bell, like that you will not miss the second part of this project. If you like the video, put a like over there, and now bye bye guys, and see you with the next video.